Yeah, we have been discussing about sources of water. We started with surface sources, then we saw groundwater as well. So surface sources again we saw ponds and lakes, streams and rivers and reservoirs, and subsurface sources we saw springs, infiltration works, and as well as the wells. So we've been discussing about wells, how to design them, how to find yield from them, etc., etc. So a well is laid in confined aquifer zone, so you can use this equation to work out yield from the well. Q is equal to, it is pi k into H2 square minus H1 square by ln R2 by R1. This is for unconfined aquifer. For unconfined aquifer you can use this equation. For confined aquifer, yield is equal to, is 2 pi kb into S1 minus S2 by ln into R2 by R1. So this is how we can work out yield from the aquifers. Okay. But before we solved few numericals also related to this. Few numericals we discussed related to this, isn't it? So let us solve one more numerical related to this. So see that a horizontal confined aquifer 10 meters thick and infinite area extent lies with its top level 25 meters below ground level. Static piezometric surface is 10 meters below ground level. During steady rate of pumping from the well at 5000 meters per day, the steady drawdown at the well is 12 meters. K is equal to 48 meters per day. Assume radius of influence is 500. Find effective well diameter. Diameter of the well you have been asked to find out. Diameter of the well means what? It is the design of the well. So you have been asked to find out diameter of the well. So diameter of the well means design of the well. This is nothing but design of well. So it is expected to get 5000 cubic meter per day of water from confined aquifer. Confined aquifer, right? And whose, what is given? Horizontal confined aquifer 10 meters thick. So thickness of aquifer is given as 10 meters. B is equal to thickness of aquifer. I wrote already all these things, okay? This is given as 10 meters. So where permeability of soils is given as 48 meters per day. 48 meters per day. And steady drawdown in the well is 12 meters. It is 48 meters per day. Drawdown in the well is, that is S max. S max is equal to 12 meters. Then what else is given? Assume radius of influence as 500 meters. Radius of influence is given, capital R. Capital R is given as 500 meters. And you have been asked to find out what? Diameter of the well. So what is the equation for confined aquifer? So for confined aquifer, Q is equal to, it is 2 pi kb into S1 minus S2 by ln R2 by R1. So actually this equation we can apply between two test wells, but unfortunately the test wells are not given. Only pumping well data is given. So when test well data is not given, what we need to do? We need to take one test well at the face of the well, right? Where R1 is equal to RW. One more test well we take it to radius of influence. So there is an option left with you. So this is radius of influence. So therefore what we do is, we take one test well at the face of the well, one more test well at the radius of influence. Somewhere here we take. Right, two test wells are taken. So one test well is at a distance R. Right, another test well is at a distance RW, radius of the well. Two test wells are taken and we apply this equation between these two test wells. We apply this equation between these two test wells to find out the yield from the well. This Q is coming from either direction. Okay, yield will be same wherever you take this one, the wells between capital R to RW, yield would be same. So here what is given? S max is given. S max means what this is? This is given as 12 meters. This is taken as S1. Then S2 is taken as 0 because at radius of influence drawdown is equal to 0. So we got everything. The only unknown is RW. So here we take, I will replace R1 with RW, which is equal to diameter of the well by 2. This is unknown. If you know RW, you can get diameter of the well. Okay. And R2 is taken as capital R, which is equal to 500 meters. It is given in the question. In the question, he has mentioned that radius of influence is 500 meters. And S1 is given as S1 is equal to S max, which is given as 12 meters, and S2 is equal to 0. Okay. Then I'll apply this equation between those two. Then I can find out radius of the well. Once I know the radius of the well, I can find out diameter of the well as well. Okay. So simple and so easy. So Q is equal to 2 pi kb into, it is 1 mark question only, 1 mark or 2 marks question, S1 minus S2 by ln R2 by R1. So if we substitute, so it can also equal to 2 pi kb into S max minus 0, S2 is 0 by ln R2 is capital R, R1 is RW. So RW is unknown. So 5000 meter cube per day is equal to, it is 2 pi into 48 meters per day. B is given as 10 meters. S max is 12. This is 0 by ln capital R is 500 meters. RW is unknown. So the only unknown is RW. You can find out diameter of the well. Come on, find out diameter of the well. Right, radius of the well. If you know the radius of the well, you can find out diameter. So what is the radius of the well from this? How you can work out? So simplify this equation. So 5000 by 2 into pi into 48 into 10 into 12. Right, this is ln. So if you want to remove that, it is e power answer. Okay, I have removed logarithmic term. So 500 by this. So I left with RW only. So 1.148 500 by RW. So therefore RW is equal to so how much you are getting? RW. What is RW value? 0.358 I am getting. So I am getting this is RW is equal to 0.358 meters. Then diameter of the well is 2 times RW. So it is 0.358 into 2. So it is 0.716 meters. That was the answer for this question. So this is how we need to work out the well problems. So well problems are also very popular in GATE exam. So they are asking questions from wells. So you should be careful about this. Okay. Now, so numericals almost completed related to wells. Now let us move to collection of water. So before collecting the water, among all sources which is to be selected, that selection is made based on certain criteria. The following points are considered to select the best source among the available. The following points are considered to choose or select the best among the available sources. So what are the points to be assessed to find out to find the best source? Of course, the first point is always quantity of water. First priority is given to quantity. Second priority is given to quality. So both quantity and quality, both of them are very, very important. If quantity accept, quality aspect, both of them it satisfy, then third point that we consider is distance between source and supply. So whichever is the nearest source, that's the best. First is definitely quantity. Quality is good, but quantity is very less. We can't meet the demand, isn't it? So therefore first priority is quantity. So quantity it satisfies, then we look the quality. Among the available, whichever meet the quantity requirement, then among them we choose the best quality water. In whichever source best quality water available, that is taken into account. That is also matching, still so many sources left with you. Then we consider distance between source and supply. Whichever is close to you, therefore cost of conveyance will be less. Then this is also satisfied. Then we consider topography between source and supply. So whichever has got plain topography, that is easy to convey. If there is a mountain, big mountain is there between source and supply, then you have to dig a tunnel. That tunneling is very costly affair just to convey water. Therefore we try to avoid such type of things. Okay. Therefore topography also important. Plain topography, even though it is little far away from the source, we consider that instead of taking a source which is close to you but topography is very bad. There is a bad topography is there, then cost of conveyance, cost of that is conveying water is difficult for us. Then fifth one is elevation. So whichever source matches maximum of this point, that's the best source. All these points are considered while selecting the source. The first priority is always quantity, second priority is quality, third priority is distance, fourth priority is topography, fifth priority is elevation. Understood? Then next. So once we choose the source, the next step is how to collect water from the source. That is very, very important. Okay? Collection of water. How water is collected. Normally 99.9% times community depends on surface water. So surface water collection is little bit tough job, because in surface water what happens is water levels highly fluctuate with the time. So water levels are not constant. Therefore what we require, we need to collect constant amount of water every day. One day you will find full water, the other day you will find very low water. But irrespective of the availability of water, we need to collect constant amount of water. So to collect that constant amount of water, there should be some kind of mechanism such that which facilitate us to collect constant amount of water. That mechanism, we need to talk about that collection mechanism. Okay. So water is collected. Water highly fluctuates in surface water bodies. Therefore, to collect water from surface water bodies, we construct one intakes. Intake is the means of collecting water from surface water bodies. So water collected from surface water bodies by means of intakes. So at least definition is supposed to know what is intake. IAS exam they are asking what are the points to be considered to locate intake for collecting the water from at a source. Okay, so intake is a structure constructed at surface water bodies. Intake is some kind of structure constructed at surface water bodies for the safe withdrawal of water or a predetermined pool ranges. So this is a textbook definition of intakes. That means what I mean to say is at surface water bodies, this assume that river flowing nearby. Okay. So sometimes water level in the river is at highest point, sometimes water level is at lowest level, sometimes water is somewhere here, sometimes water is flow above the banks also. But irrespective of the water level at the source, this is source. So we need to collect a constant amount of water. Normally this collection is made with the help of pump and pipe. Those pump and pipes we install to collect water from the source, they should be protected irrespective of the water level at the source. They should not wash away along with water. So normally what happens when flood occur in a river, then what happens that first thing that disappear from the river is pipe and pump only, which we use to collect water. So pump and pipe are installed here. This is a pipe, collection pipe, and this is a pump. This is a conveying pipe, and in between there is a pump. So whenever flood happens, so this is washed away along with this water. Water level increases further, this will move away. So till flood recedes, no one is there to go to the river to install a new pump and pipe for further collection. So to recede flood waters at river, it takes 3 to 4 days time. So 3 to 4 days, if you don't supply water to the public go mad. They go against you. So therefore, irrespective of availability of water at the source, we need to collect constant amount of water. So that is not possible, right? That is not possible without intake. This is a pipe, this is a pump, this is also pipe. So which collect always Q amount of water which is conveyed to your city. Your city is somewhere here, river is flowing here, right? From the river you have to collect water and take to your city. So like this is a river. Oh sorry. So this is a river which is flowing nearby. So we install a pump and pipe here. This is a pump which is extended into this, and we collect water, and this water is taken to your city. This is your city. From river you have to collect water and you have to take back to your city. This is pump. This is pipe. So pump and pipes are required to convey water. So this pipe is taken and taken to city. There it is purified and then supplied to public. Understood? So if you water level highly fluctuates, summer what happens? Water level depresses to so low level. When it goes to so low level, again you can't collect water properly. So water is not available to this pump. You can't extend this pipe length also. Even if you extend also, nothing happens because this is a suction pipe. Suction has got a limited capacity. So at limited height, it can lift water. Beyond that height, nothing happens. Okay. Therefore, within that suction capacity, then we have to install that a pipe inside the source. Then conveyance purpose, any distance you can convey. That is not that difficult. Okay. Therefore, what we do is, so install pump and pipe here. So instead of collecting straight away from source, something like this. So this is a source. So instead of installing, what we do? We construct one tower here. One massive tower is constructed. This massive tower which is constructed at the bed of a river. So with footbridge and all, right? With proper arrangement for people to carry out the job. So footbridge also we provide. So therefore they can walk and reach there. So this massive tower constructed at the bed of the river to collect water is called intake. This is called intake structure, intake tower or structure. So what it contains? It contains openings. So there are so many openings are provided to this. One opening is provided at highest flood level. One opening is provided at maximum water level. One more opening at normal water level. One more opening provided at lowest water level. Through these openings, it draw water into intake tower. So it draw water into this tower. So from there, you can pump out water by installing pump and pipe inside the tower. Even though flood happens in a river, so pump and pipe, both of them are secured. So they are operated from the top. So walls will be there. With the help of walls, we operate them. So where is your pump and pipe? Your pump and pipe are installed here. This is your pump. This is your pipe. Put valve and all. So this pipe will be good taking water to your city. So your pump and pipe is protected completely. Even highest flood happens. This is pump. This one is pipe. So we'll collect water. Intake collect water first. So openings are provided. One at highest flood level. Highest flood level one opening. Maximum water level one more opening. Normal water level one more opening. And lowest water level one more opening. Okay. Medium water level, whatever it may be. So different places openings we provide through which it draws water. Always collection is made from the top. We don't collect from the bottom. So whenever water level is at highest level, from there that particular opening is, that valve is open and it start drawing water from there. So that is how we can collect water. Otherwise, bottommost always you open valve at lowest level pipe. If you collect, sediments also get into this tower. Tower will fill with sediment. So it become a sedimentation tank. So we do not allow any sediment inside. Only water we collect. That water only we pump out. Okay. This tower is called intake tower. So it is a massive structure it is. So intake is a structure constructed for the safe withdrawal of water over a predetermined pool ranges. These are the pool ranges. Different pool ranges. Openings are provided. Okay. Through that openings, water get inside. So water get like this. Water will move into this intake tower. From there, we pump out water to the city. So water will go to city. Constant amount of water we can collect. When sufficient amount is collected, then we can pump out. That tower is called intake. Understood now? Hope it is clear to you. Now, there are so many types of intakes. Okay. Intakes, basically there are two types of intake. One is dry intakes, the other one is wet intake. So wet intake means it collects water and store water temporarily before water is discharged into pipe. So it collects water from source, store water in between temporarily, and discharge and deliver water as and when we need. The tower is called intake tower. Example for wet intake is river intake. Intake constructed at river is essentially wet type intake, because it wet the walls of the intake tower. Inside intake tower it is completely wetted, whereas dry intake, right? Dry intake only collect water. As soon as it collect water, immediately it deliver that water, it discharge that water into pipe. Collect and discharge without storing in between. Example is reservoir intake. So intake constructed reservoir is essentially a dry intake. It doesn't store water in between. So as soon as it collect, immediately water is delivered, discharged into conveying main or transporting pipe. So there is no storage in between. So like that they are classified. They are also classified based on the source at which they are constructed. They are river intake, right? Reservoir intake, lake intake, canal intake, etc. Like that, different types of different sources. Purpose is same only. Some of them are dry, some of them are wet. Only except reservoir intake, remaining all are wet intakes only. Except reservoir intake, remaining river intake, lake intake, canal intake, all of them are wet intakes only. Okay. Purpose is same. Same purpose we use them. Understood? Hope it is clear to you. Then what are the points to be considered to locate intake? So this is a river flowing nearby. This is your city. This is your city or a town or a village, whatever it may be. This is a source. A river is a source. So from where you need to collect this water, where we need to locate intake? Along the length of the river. So first point to be considered is, so the city is producing wastewater, sewage. That sewage also disposed into this river only. The wastewater produced by this river, that's called effluents. They are called effluents. Wastewater effluents, they are disposed into river. So where you need to locate this intake tower? So this is, river is flowing like this, the upstream side of the river. With respect to this point, this is downstream side of the river. So where you need to collect your intake tower? Upstream side of disposal of wastewater or downstream side of disposal of wastewater? If you choose upstream side of disposal of wastewater, if you locate intake tower, you collect reasonable quality water. If you locate on the downstream side, the wastewater joining the river, that contaminate river water, already river water is dirty, some more dirt is added, it becomes super dirt water. So therefore, we try to locate intake tower, intake always on the upstream side of point of disposal of wastewater. So located on the upstream of point of disposal of wastewater. Somewhere here you have to locate point of disposal of wastewater. That's the first point you need to keep in your mind. And second point you need to keep in your mind is it should be located inside the source, not on the bank of a source, at a bed of a source, where reasonable depth of water is available throughout the year. Located at sufficient depth inside water body. Located inside water body where sufficient depth of water is available throughout the year. Located at a place located at inside the river or inside the source where sufficient depth of water is available throughout the year. So that collection becomes so simple and easy. Where sufficient depth is available round the clock throughout the year, sufficient depth is available. And it should not be located in the meandering portions of a river, where river is taking so many number of turns. So understood no second point? I hope second point is clear to you. Second point means it should not be located on the bank. It should be located deep inside the water body, so that at the banks what happens during summer, water is not available. So you need to locate here, intake tower. From here you can take water. This tower is located here, somewhere here. So where sufficient depth is available. So even though water is not there at the near to the banks, but inside it is water is available, it can comfortably draw water. That is the point. Understood? And third point is we should not locate it where river is taking so many number of turns. Right? Meandering portion, turning river is called meandering portion, meandering river. So we should avoid. We should locate at where straight stretch of a river is there. Should not be located in the meandering portions of a source. That is also important point. This question is been asked in IAS exam, ESE exam, which among the following statements are true with respect to locating the place at a source for intake, for locating the intake. So this question is been asked in ESE exam. So should not be located at meandering portions of a river, portions of a source. Where river is taking so many number of turns, there should not be located. It should be located where straight stretch of, where river is flowing straight, there you can locate. Because meandering portion is not a correct point because there is scouring. So that intake tower also get affected by currents, water currents, and intake tower also scoured off. So that's to prevent that problem, it should be avoided. So straight portion is there is no scouring problem. Okay. Then fourth point is it should be far away from navigational point, located far away from navigational points. Far away from navigational points. This is also important point because rivers, water bodies are used as a means of transporting goods by using a ships, vessels or steamers. Cargo is transported, isn't it? So they will be discharging their waste into water, contaminating the water. Therefore, it should be away from navigational points. So close to navigational points, we should not locate intake tower. In addition to that, the place where we locate this intake tower should be accessible even during the floods. People has to go and work there. See now, you have constructed a tower here, so they'll go there and carry out the job, opening the walls, closing the walls, opening the or switching on the pump. So people will be working here. The workers should go there and carry out the job. The place should not be flooded with water. So look, the place should be accessible even during the floods. Located at a place where it is accessible even during floods. It should not be submerged underwater. That means elevated point you need to locate. Should be located at a place such that it is accessible even during the floods. So accessibility is there, men can go there and work, carry out the job. Even during floods. So all these points are to keep in your mind before we decide a place to locate intake tower. In addition to that, there should be enough space available, future expansion, right? It should be as far as close to the city, it should not be far away from the city. As far as choose, it is very close to city, so that the cost of conveyance will be less. So all these points are taken into account, but these are important points, okay? So keep them in your mind, and if at all they ask any questions, you answer them. So multiple selective questions also they can ask. Which among the following points are correct in locating the intake tower? So in such case, you can tick mark whichever is right. Okay, that's all. This is about intakes. Intakes are the means of collecting water from surface water bodies. Clear now? So next, conveyance of water. So after collecting the water, next step is conveyance of water. Conveyance of water means what? Transport of water. Water transport. So from the place of collection to place of supply, water is conveyed all the way from the place of collection to place of supply. Understood? Water transport. Conveyance of water means how water is transported. Which you have to use? Goods, or a train, or a car, or a bus, or a auto, or a rickshaw, or a truck. So for individuals they get by using the trucks and all, isn't it? But we don't use trucks. This is a bulk water supply system. In bulk water supply system, employing trucks, this and all, practically not possible. Therefore, so whenever we talk about conveyance by using two types of conveyance system. So water is conveyed from the place of collection to place of supply. Conveyed means transported. Place of collection to place of supply by employing any one of the following systems. Any one you can use. Conveyance systems or transport systems. One is called gravity conveyance. The other one is called pressure conveyance. Gravity conveyance and pressure conveyance. There are two types of conveyance. One is called gravity conveyance. In gravity conveyance, what happens? By gravity we can convey water, right? Gravity conveyance require what? Open channel conveyance, or open channels are used. That's called canals. It's called open channel conveyance. Example is canals. Canals are used. Second one is pressure conveyance. Pressure conveyance is closed conduit conveyance. Closed conduit conveyance. Example is pipes. We use pipes, set of pipes to carry water from the source of from the source to community. So till we deliver water to the community, we use set of pipes. So normally pressure conveyance is preferred to gravity conveyance. So the reason being, over a period of time, pressure conveyance is more economical than gravity conveyance because we are located in tropical climate zone. So losses, evaporation losses and all very high. Therefore, without any loss of water, by maintaining the quality, without changing the quality, you want to take water from source of collection to source of place of supply. So better is pressure conveyance. So pressure conveyance is preferred to gravity conveyance. So whenever we talk about pressure conveyance, one design question they are asking. Preferred to gravity conveyance. Pressure conveyance is preferred to gravity conveyance. Whenever we talk about pressure conveyance, then you are expected to design the system. In open channel, design of open channels, so you can design the canal system to convey water. But in case of pipes, So using the concepts of fluid mechanics, you can design the pipelines, diameter of the pipe and all. So design of pressure conveyance, they are asking questions in GATE exam, ESE exam. Design of pressure conveyance. Design of pressure conveyance include fixing the two things. One is the size of the pipe required and as well as and capacity of the pump required. So design of pressure conveyance include fixing the size of the pipe. One is fixing the size of the pipe. What is the size of the pipe? Diameter of the pipe. Diameter D. This is. Second one is, what is second one? Finding the capacity of the pump. So pump and pipe are required. What pump does? That is BHP of the pump, brake horsepower of the pump. Both pipes and pumps are available ready-made in the market. Know your pipe size, know your pump capacity, go them, buy them, fix them, use them. Simple as such. Design means we don't design the diameter of the impeller, the blade angle, right? This and all not required. Efficiency, this and all not required. What is the diameter of the pipe required? What is the capacity of the pump required? Because both of them are ready-made available in the market. Know your pipe size, know your pump capacity, go to the market, buy them, fix them and use them. Simple as such. Civil engineers need not do any design of any internal parts of this pipes and pumps. The only what is the diameter of the pipe required, size of the pipe required, what is the capacity of the pump required, because it has to accommodate Q amount of water comfortably and all the way carry that water for a distance L meters from the source to supply. So for that it require energy. So pump give energy to water. Using that energy, Q amount of water flow smoothly in a pipeline. So that's why these two things are very, very important. Then how you can design? Any idea? Yes, come on guys. So let us see design of pressure conveyance. So we design the system to convey water all the way from the lowest water level at a source to highest level where water is to be discharged. So lowest water level at a source. This is pump. This is pipe with footfall and all we provide here. This footfall. Okay. Here pump is there. So this pump convey water and deliver water into at a place at a highest level. This is critical most situation we are taking. We are taking where it deliver into reservoir. Before we treat, we collect water, we store in reservoir. From there, water is treated and supplied to the public. So this pipe has to deliver. This is called suction pipe. This is called delivery pipe. So lowest water level to highest level, you need to take out water. Lowest water level, this highest point where delivery is made. This is the highest level. Highest point. Lowest water level to highest point, you have to take water. This is a reservoir. This is a source. Source could be a river, source could be a lake, source could be a reservoir, whatever it may be. This is source. Okay. Water collected from source. This is supply. And water is supplied here. And delivered there, other delivery point that is. Okay. So what you have to find out? This you have to find out. What is this? Diameter of the pipe required. And this is brake horsepower of the pump required. This is pump. This is pump. This is conveying pipe. Conveying pipe. So these two things is known as design of pump and pipe. Diameter and BHP. So it has to convey water all the way. It has to take that water L meters from source to supply. Against a head, total head, H meters. From here to here, water level difference is called H. Okay, like this. So how to design this? Any idea? Those who are watching this live session, any idea is there for you, with you? Just comment there. Okay, no idea. Okay, anyway, no issue. Learn. So how we collect? So diameter of the pipe we can work out by using either Darcy's equation or Hazen-Williams equation. So diameter of pipe, D found by 1 using Q is equal to area into velocity, 2 using Darcy's equation, HF is equal to FLV square by 2GD, or otherwise this is almost same as FLQ square by 12.1 D power 5. Okay, D capital I took, no, 2GD D power 5. You can use this equation, or otherwise one more option left with you is you can use Hazen-Williams formula. V is equal to 0.85 CH R power 0.63 and S power 0.54. So in this called R is called hydraulic mean radius, which is equal to wetted area by wetted perimeter. So it is running full, therefore it is D by 4, and S is equal to slope of hydraulic gradient line, nothing but slope of the pipe, which is nothing but H by L. Slope of hydraulic gradient line, which is nothing but H by L. So either you can use this or use this. So choice is left to you. If F is given, you are expected to work out by using Darcy's equation. This is called Darcy equation. Darcy-Weisbach equation. Fluid mechanics, you come across this with equation. You studied about this equation in fluid mechanics. Darcy-Weisbach equation. This is, or otherwise this one is Hazen-Williams equation. So when F is given means you are expected to find out Darcy-Weisbach equation. When F is not given, CH is given, you are expected to work out by Hazen-Williams equation. Okay, CH is Hazen-Williams constant. F is equal to friction factor. F is friction factor in that equation. CH is Hazen-Williams constant. Hazen-Williams constant. So like this they will give you. So using that you can find out Q is equal to area into velocity. How to find out Q? Q is equal to population into per capita water demand. So population into per capita water demand will give Q. This Q is equal to area into velocity, which is equal to pi by 4 D square into V. So this way. So two equations are available. So you can work out. So V also unknown, D also unknown. Two equations are available. Using these two equations you can find out diameter of the conveying beam. Understood? Let us try one question. Okay, let us try one question. Example. A town supplies water. A town with population 50,000 supplies water at a rate of 200 LPC from a source which is 8 kilometers away from it. The elevation difference between source and city is 10 meters. If the elevation difference between source and supply is 10 meters, find the diameter of the conveying main. Find the, like this question may be asked related to environmental engineering, not pure fluid mechanics problem. Slightly fluid mechanics concept only, but it is applied to environmental engineering. So normally fluid mechanics means they will give you Q. Environmental engineering, same question if they ask, indirectly they will give Q value. So you have to work out Q as well. Understood? Diameter of the conveying pipe or conveying main. Conveying main means pipe only. Conveying main. Main means pipe only. So this was the question. Come on, how to proceed this question? So what is given to you? Indirectly given Q value. So Q value is given as population into per capita water demand. Q is equal to population into per capita water demand. So population is given as 50,000. Per capita water demand is 200 LPCD. So this straight will get liters per day. This you can convert into meter cube per second. How to convert liters into meter cube per second? 1 liter is equal to 1 meter cube is equal to 1000 liters. 1 liter is equal to 1 by 1000 meter cube. So divide by 1000. Now this become meter cube. Days into seconds. So 24 into 60 into 60. 1 day is equal to 24 into 60 into 60 seconds. Then this become meter cube per second. Understood? So this is how we have to work out. So let us see. Let me calculate on my own. So 50,000. I am also working out along with you. Because you should feel the difficulty at the time of preparation only. You should not feel any difficulty at the time of writing exam. Therefore, you should work it out by using virtual calculator. So it is 0.115 meter cube per second. Suppose variations are given. Maximum demand is equal to so-and-so average demand, something like that is given. We can use that variation also. So nothing is mentioned here. So therefore we design for average only. If anything is mentioned, we design for maximum. Otherwise we always design for average only. Remember that. So we don't assume. In competitive exam, nothing is assumed. We don't assume anything in competitive exam. So whatever information is given in the question, with that information only we go ahead with it. Okay? No assumptions. Even though you are right, in practice you can assume and work out. Assuming maximum demand is equal to 1.8 times average demand, something like that, we can work out. But here, no assumption. No assumptions are allowed in competitive exams. Understood? So you should be careful about this point. Don't assume anything. You proceed with the given information. Understood? So Q is given 0.115 meter cube per second. Okay? Point 115 meter cube per second. Q we got. Next, what you need to do? So, what is given indirectly? HF is nothing but head loss due to friction. That is nothing but elevation difference between source and supply, which is given as 10 meters. So, distance between source and supply is given as 8 kilometers. Nothing but 8000 meters. Right? So, FL Q square by 12.1 d power 5. So, HF is equal to, so I can use that equation and can find out. So HF is equal to, it is FLV square by 2GD. Friction factor is given. Okay, I forgotten to give friction factor. So take friction factor F is equal to, so whenever friction factor F is given means you are expected to find out by using Darcy-Weisbach equation. Whenever CH is given, you are expected to work out by using Hazen-Williams formula. That's how you need to. So this is FL Q square by 12.1 d power 5. So this is 8 meters elevation difference between source and supply. This is 0.01. This is 8000 into 0.115 square by 12.1 into d power 5. So diameter of the conveying pipe is equal to d is equal to how much? Come on, work out. All of you. What is d value? Okay. So d value is equal to, it is, I am working out on my own, 0.01 into 8000 into 0.115 square by 8 into 12.1 whole power 1 by 5. So diameter of the pipe is 0.534. So I got 0.534. Exactly 0.534 meter size pipe may not be available. Whichever pipe available nearest size, that is used as a conveying pipe. Nearest size may be 0.6 meters diameter. 0.6 meters may be available, or 0.55 is available. Then we can fix it and use it. But we don't go for nearest lower value. Nearest high value you can take. Okay, that's how we can find out. Similarly, Hazen-Williams formula. When you are expected to work out by using Hazen-Williams formula, things will be given like this. Question will be given like this. Sorry. Example. A town supplies 10 mld water from a source which is 10 kilometers away from it. If the elevation, if the water level at the source, so it is to be conveyed, indirectly they will give H value. Water is to be conveyed from a source, water conveyed from a source at RL 90 meters to at RL 90 meters and delivered at reservoir okay, delivered at reservoir at RL 100 meters. Find diameter of the conveying pipe required. Conveying pipe required. If Hazen-Williams coefficient CH is equal to 100, take otherwise. Take Hazen-Williams coefficient CH is equal to 100 means okay, you are expected to work out by using Hazen-Williams formula. So indirectly given 10 kilometers, 10 meters. Therefore, what is given? Distance between source and supply is 10 kilometers. That is 10,000 meters. And elevation difference between source and supply is RL 100 to 90. It is converted from 100 to 90. 90 to 100. So 10 meters it has to be lifted. Okay. That is H is equal to. Then what else you require? So Q is given as 10 mld. 10 million liters per day. How to convert this into meter cube per second? It is 10 into 10 power 6 liters per day. How to convert liters into meter cube? By 1000. Now it is meter cube per day. How to convert meter cube per day into meter cube per second? By multiplying with the denominator 24 by 60 into 60. Now it is meter cube per second. So same thing you will get. Last question we got 0.115, right? Same thing we will get here also. But last question, friction factor is given. Therefore, indirectly he is expected to work out by using Darcy's equation. But in this question, he has not given friction factor. He has given Hazen-Williams constant. Therefore, you are expected to use Hazen-Williams formula. What is the Hazen-Williams formula? So V is equal to, okay, sorry, 0.85 CH into R power 0.63 and S power 0.54. So Q is equal to area into velocity. So from this you can write velocity is equal to Q by area. So Q by pi by 4 d square. So you have to find out what? and R is equal to D by 4 and S is equal to H by L. So everything is known. So formula substitution. So if we substitute in the formula, V is equal to Q by A. So 0.115 by pi by 4 D square is equal to, it is 0.85. CH is given as 100. R is unknown, D by 4 to the power 0.63. 0.85 CH, R power 0.63, S power 0.54. S is equal to H by L to the power 0.54. This is the equation. Okay, I'll substitute later. So this is the one which we're supposed to use in this question. So V is equal to Q by A. So Q is 0.115, A is pi by 4, D square is 0.85 into 100, D is unknown, 0.63, H by L. H is given as 10 meters, L is 10,000 meters, to the power 0.54. So the only unknown is D, find out D. Come on, work out D. Let me see how many of you work out. Because in GATE exam calculators are allowed, so comfortably you can use calculator. IAS exam calculators is not allowed, therefore without calculator little bit difficult to solve this question. Okay. Into 100 into 0.85. Okay. Into pi divided by 4. Inverse 1 by x into 0.115 whole power 1 by 2.63. That is how you got to work out. So I got 0.46 meters. So diameter of the conveying pipe required is 0.46 meters for this data. I may be wrong, you verify, okay? So I worked out like this. Clear now? Hope it is clear to you. So that is how we design the conveying pipes. Okay then. Next, so once we know how to fix the size of the pipe, next step is how to fix the capacity of pump. How pump capacity is fixed. Let us see. Okay, I'm suffocating little, so let me remove my jacket. Kindly excuse me for inconvenience. Inconvenience is regretted. So why not attending? Many people, very few are attending. Okay. Then the next is pump, BHP. How to find out brake horsepower? This part is removed from the GATE syllabus. So hydraulic missions are removed. In hydraulic missions topic they teach you. But anyway, brake horsepower is equal to, it is water horsepower by, right, efficiency of pump and efficiency of motor. It's called brake horsepower. Brake horsepower. So water horsepower, WHP means water horsepower. How to find out water horsepower? How much energy is to be given to the water to convey water all the way for L meters against a head H meters. The water horsepower. This water horsepower is equal to, it is gamma W into Q into H by 0.746. So and so HP will get straight away. Understood? So power is nothing but force into velocity. So how much force we need to apply to convey water with so and so speed inside the pipe? That's called power. So first we need to work out water horsepower. Then we need to work out this one. H is equal to, it is a total head against pump has to work. It is a total head against pump has to work. This total head is equal to It is sum of static head plus dynamic head. This total head is equal to, it is H static plus H dynamic. Right, understood? Static head means what? Head does not change. So normally, this is our pipe, pump, this is our pipe. So we have to convey, worst case, lowest water level will take. So beyond this, no water drop down. And we take this water and deliver it to highest point. That is reservoir. Right? Highest point we deliver this water. This is a critical most situation. So reservoir we deliver water. Here we store water. That water we store in a reservoir. Lowest level to highest level we take. So what capacity of pump required? So this is called static head. Pump level to lowest water level at source is called H static. This is called static head. H static. Oh sorry. This is suction head. Sorry. This is called suction head. Okay, it's a suction. Then pump level to highest level at a reservoir. Pump level to highest level at reservoir is called H dynamic. From here to here, this is called, this is X stat, H suction, H delivery. Delivery head it is called. Not dynamic, delivery. H delivery. Right? Then head loss due to friction is called dynamic head. H dynamic is equal to with head loss due to friction, which is nothing but FLV square by 2GD. H delivery head. This is pump level. Pump level to reservoir level. This is reservoir. Highest level at reservoir. This is source. Lowest level at source to there you need to take. So this H is equal to, this is H static plus H dynamic. H static is equal to H suction plus H delivery. Delivery head plus suction head is equal to static head. This is called H static. This is head dynamic, H dynamic, dynamic head. So static head plus dynamic head is equal to total head. Against pump has to work. So that's how we need to calculate. That value we are substituting this. First we'll get water horsepower. While transferring water from pump to, while transferring water from motor to pump, there is some energy loss. Right? Pump to water, there is some energy loss. To account for energy loss, efficiency of pump and efficiency of motor is. So finally what you can write? So this brake horsepower is equal to, so it is water horsepower by efficiency of pump and efficiency of motor, which is equal to gamma W into Q into H by 0.746 into efficiency of pump into efficiency of motor. Usually in the ESE exam, conventional they are asking. Definitely for 1 mark without calculator, difficult for you. So therefore ESE exam also ruled out. GATE exam they have removed the syllabus. Turbines, pumps, they have removed the syllabus from 2020 onwards, isn't it? So no need of hydraulic missions. Clear now? Hope it is clear to you. That's all. So this is about conveyance system. Similarly, the gravity conveyance is designed by using canals and all we designed by using open channels. So anyway, open channel topic is there they teach you in detail. So just it also we use same. Q is equal to area into velocity, right? That formula we use. Then one is velocity is equal to, we use Manning's formula here instead of Hazen-Williams formula. That's for pressure flow. This is for gravity flow. R power 1 by n, R power 2 by 3 and S power half. So these two formula are used, R power 2 by 3 and S power half. So using these two formula, there are two unknowns here. Those two unknowns you can find out. One unknown is diameter of the conveying pipe. One of the unknowns is dimensions of the open channel. From this you can find out rectangular means B into H. Trapezoidal means width of the channel, depth of the channel. Width of the channel, bottom width of the channel, top width also to find out. If circular means diameter. Circular generally we don't use gravity conveyance. So normally trapezoidal or rectangular we use. Dimensions of canal will work out with the help of this. So where is the dimensions? A. From A. Wetted area. So in this also R is equal to. So in this also what? A is equal to. If it is a canal means we'll find out A is equal to what? This A is equal to B into H. So we'll fix up width of the canal and depth of the canal. If it is rectangle or trapezoidal, either rectangle or trapezoidal. Triangular normally we don't use. Triangular cross sections we don't use. This is cross section area. This is cross section area of canal. Second one is gravity conduit. So what is important? To carry water, velocity of flow. That velocity. Right? Proper flow velocity has generated. To generate velocity, what is required? Proper hydraulic gradient is required. So R is equal to, it is hydraulic mean radius. This has to work out. Which is nothing but wetted area by wetted perimeter. Wetted area by wetted perimeter. Hydraulic mean radius. Okay. In addition to that, so what else is unknown? R power 2 by 3 S power of. S is equal to slope of hydraulic gradient line. Slope of hydraulic gradient line, which is nothing but slope of canal. Bed slope of a canal. So this is also important. These two things, finding cross section area, finding slope is very, very important. Bed slope of canal. So finding these two things is called design of pressure conveyance. Finding cross section area, finding bed slope of a canal. That's all. So open channel topic is there. There they teach you in detail regarding how to design the canal system or open channels. Okay. Civil engineers, canals are very, very important. They are part and parcel of our life. Okay. Anyway, generally we prefer gravity pressure conveyance to gravity conveyance, because gravity conveyance initially it is more economical, but over a period of time, if you see, pressure conveyance is more economical than gravity conveyance, especially in tropical climate zone where evaporation loss are very, very high. Open channel means water evaporates. The loss of water that evaporates, we calculate over a period of time, that is much more than the energy that we give in pressure conveyance. Okay. Over a period of time, if you work out, pressure conveyance is recommended to gravity conveyance. Instantly work out, gravity conveyance is more economical than pressure conveyance. But we operate this system for long period till the end of the design period. So over a design period, if you see, pressure conveyance is better than gravity conveyance. Therefore, we recommend that maximum. That's all. This is about conveyance of water. So once water is conveyed, once this water is taken to your community, then next step is we need to treat that water and supply that water to public. So, but before treatment of water, what you need to do? You have to test water. So that's called water quality. We test water quality. Water quality is found by testing of water. This topic is very, very important in competitive exams. Okay, very, very important. From this topic you will get definitely 1 or 2 questions. So therefore, definitely minimum 1 question, maximum 2 questions also, sometimes 3 questions also you get. You will get 1 to 3 questions. 1 2 marks question, 2 1 mark questions, or 1 mark question, 2 2 marks, or 2 2 marks 1 mark questions, 1 2 marks question, or 2 2 marks questions, or 1 1 mark 1 2 mark, like that. 1 to 3 questions you will get from this topic. So this topic is very, very important. For civil engineers, this topic is little tough because civil engineers are poor at chemistry and all, chemistry and microbiology. So there you try to exploit maximum. Where you try to, you know our weakness, you try to play to our weakness. So with our weakness you will play. So therefore you are supposed to be very careful regarding this. Okay, water quality. Before we treat water, water is tested prior to treatment and water is tested after treatment. So water quality is tested 2 times. Once before treatment. Of course, water treatment is very, very important. for engineers especially. We have to design the treatment system. That is why engineers are required for municipal corporation. Water treatment. So this water is treated and supplied to public. So before treatment, whatever water we collect from a source, that water is called raw water. Raw water is full of impurities. Full of impurities. Whatever water we collect from the source is full of impurities. Good impurities are there, bad impurities are there. There are some impurities which are in good in water. So good impurities we ignore, bad impurities we remove by water treatment, by purifying the water. Then by after treatment, this water become wholesome water. What is wholesome water? Wholesome water is that water which is not 100% pure, at the same time does not contain anything harmful to human life. Does not contain impurities harmful to human life, human health. Impurities harmful to human health. Such type of water is called wholesome water. You need not remove all of the impurities. Only bad impurities we remove. Good impurities we ignore. Anything other than, so bad impurities in water are removed. Good impurities we ignore. They are removed from water by treatment. By applying treatment, we remove from water. Then water become wholesome. Wholesome water is supplied to public. Therefore, this treatment is very expensive. Treatment is very, very expensive. So every day we don't treat in the same fashion. So the kind of treatment given to water, that depends on the kind of impurities present in water. Isn't it? See, now this is a revision batch. Here I need not teach in detail. All information is not required. Only the important things we need to cover, so that it is helpful to you, helpful to student community. Without wasting our time, we try to cover maximum important things so that we can maximize score in that. I need not teach definitions and all. Every definition is not required here, isn't it? So exactly same way, we are specific. This water treatment is specific. It is decided based on the specific purpose. You are using for drinking purpose, treatment is different. You are using for some other purpose, industrial purpose, treatment is different. You are using for some other purpose, treatment is different. So every time water is not treated in the same fashion. Therefore, the treatment is decided based on the amount of impurities present in water. Therefore, to find out impurities present in water, we test water before treatment. So water is tested, raw water is tested before treatment. Then after treatment also we test water. Here, once again water is tested. Here, wholesome water, whether it attained complete wholesomeness or not. That's what we try to find out, right? After applying, after treatment also. Okay, understood now? So before treatment also we need to treat water. After treatment also we need to test water. Test water. Corona treatment. So corona, how you detect corona, you suffering with corona or not? So they treat you, they test you. Rapid testing, antigen testing, something testing. So once treatment is over, again they test you. How they test you? Whether you recover completely from the disease or not. To ensure, to confirm, oh, he is completely recovered, he is fit to move in the public, something like that. Still, disease is not completely cured, then some more time they continue treatment. Exactly same way, here also water. Water also treated in the same fashion. So before treatment, raw water is tested. After treatment, we have to ensure ourselves how far this raw water is converted into wholesome water. Wholesome water is that water which is not 100% pure. At the same time, it doesn't contain anything harmful to human health or human life. It's called wholesome water. So pure water means distilled water. Pure water nobody likes to drink. Water should contain certain impurities, good impurities. Then only public like it. So water should contain little calcium, little magnesium, little iron, little manganese, little hardness, little chlorides, little fluorides. This and all present in water, that is good for health. More they are present, sometimes they are objectionable. Little they are present, they are good for health. Similarly, there are some impurities which cause badly damage your health. Such type of impurities are called bad impurities. Those impurities we have to check from water by applying treatment. So therefore, Two times we come across with water testing, once before treatment, once after treatment. So what we test? Impurities only. In either case we test impurities. These impurities in water we broadly classified into three categories. Okay? We broadly classify these impurities three categories. One is suspended impurities based on their size. Second one is colloidal impurities. And third one is dissolved impurities. Suspended impurities, colloidal impurities and dissolved impurities. These are, they are broadly classified into three categories. This specifications of the suspended, colloidal and dissolved impurities is important for exam point of view. One is suspended form. So when the size of the impurity is anywhere between 10 power minus 1 mm to 10 power minus 3 mm, such type of impurities are called suspended impurities. Sometimes we express in microns. So 100 micron to 1 micron, they are called suspended impurities. 1 micron is equal to 10 power minus 3 mm or 10 power minus 6 meters. Okay? 100 micron to 1 micron. Micron. This is called micron. Micron meter. Then colloidal impurities. When size of the impurities are range anywhere between, so we try to remove these impurities from water by applying treatment. 10 power minus 3 mm to 10 power minus 6 mm. That means 1 micron to 10 power minus 3 microns. They are called colloidal impurities. When impurity size is range from anywhere between 10 power minus 3 6 mm to 10 power minus 1 8 mm, they are called dissolved impurities. So sugar dissolved in water, it doesn't visible to you but very much present in water. So like that, impurities also very much present in water but they are not visible to you. 10 power minus 6 mm to 10 power minus 8 mm or 1 micron, 10 power minus 3 micron to 10 power minus 5 microns. Understood? This is very, very important classification because whenever we treat water with respect to size only we deal. These impurities present in physical form, chemical form and biological form. Okay, suspended impurities, they are also present physically. Some colloidal impurities, dissolved impurities, they are present in chemical form. Biological and impurities and chemical impurities present in colloidal form and dissolved form. Suspended impurities present in physical form. Therefore, we try to find out three water qualities: physical water quality, chemical water quality and biological water quality. Physical water quality is to find out visible impurities, right? And colloidal and dissolved impurities are invisible, they are called micro. So suspended impurities are called macro. Suspended impurities also known as macro impurities. Suspended also known as macro impurities, whereas colloidal and dissolved are micro impurities. Macro means they are visible to naked eye. Micro means not visible. Not visible to eye means they are micro. So usually suspended impurities are known as physical impurities. Physical impurities are suspended. Example for suspended impurities: physical. Physically they are, you can feel them. Physical impurities. Physically you can sense them. Whereas colloidal dissolved impurities are they are in chemical impurities and biological impurities. Chemical impurities, chemical substances, they are present in colloidal form and dissolved form, mostly dissolved form. And biological impurities means microorganisms, they are present in both colloidal form and dissolved form. Understood? So all we try to find out physical impurities, chemical impurities and biological impurities. So physical impurities in suspended form, mostly physically they are, you can feel them, okay, whereas chemical and biological impurities, they are micro, they are not visible to you, okay. So therefore we try to find out three water qualities. One is called physical water quality. By finding physical impurities we work out physical water quality. Second one is chemical water quality. Three types of water quality will work out to find out total water quality. One is physical water quality, second one is chemical water quality, and third one is biological water quality. Okay, physical water quality we work out by using physical impurities. If you find out physical impurities, then physical water quality will get. And colloidal and chemical and biological impurities are normally in colloidal and dissolved form. Colloidal and dissolved impurities are. Physical water quality is defined by physical impurities, and colloidal dissolved impurities define chemical and biological impurities. That's how we can find out three water qualities. So let us, without wasting much time, let us start the first one, physical water quality. So boring now. Theory is boring, but they are asking problems, numericals. So numericals are to learn. So no option, you can't run away. When you are facing this tough competition, you should be alert always. You should learn maximum. So wherever scope and chance is there for numerical, there you need to focus more along with the concepts. So physical water quality first, let us try. So physical water quality is defined by the following parameters. There are 4 parameters. So by using those parameters, we work out physical water quality. The following parameters define physical water quality. Physically, how it is pleasing, because physical appearance is very important for consumer. Consumer accept water only it appeals to him. So it appeals to the consumer only if he is comfortable. He can't see anything in water, you don't smell anything bad in water, you don't taste anything bad in water, so you don't feel anything in water, such water only will accept it. So he will give more importance to physical appearance. Therefore, though physical water impurities are not so dangerous, but still we try to work them out because it is objectionable to consumer. So consumer point of view only we think always. One is called temperature. Second one is color. Third one is turbidity. Fourth one is odor and taste, or odor and taste. Odor means smell and taste. So these 4 parameters define physical water quality, because the parameters which you can feel, which you can see, which you can sense, which you can touch, they are called physical water quality parameters. So physical water quality parameters define those water quality parameters which respond to human sensory system. We have got eyes, we have got nose, we have got ears, we have got tongue. Using that human olfactory system, without our knowledge, we test physical water quality. If it pleases you, consumer accept. If it doesn't please the consumer, water doesn't please the consumer straight away reject it. Simple. Consumer acceptance is the first priority. Which car has got more demand, Ambassador car or Maruti Brezza car? Ambassador car is the best for Indian roads, but its physical appearance is bad. It is like this. Whereas Maruti Brezza is it is sleek design, isn't it? Brezza car, if you see, so it will appear like this. Nice design it is. So everybody likes to drive Such type of cards only for Indian market. Indians give so much importance to physical appearance. This is Brisa. This is Ambassador. Which you will buy? Which you drive? Ambassador or Brisa? This best car for Indian roads, which is made up of rugged steel. The engine is rugged. Even accident happens also, passenger engine is protected completely. But whereas Brisa, most of the people who are dying in the accidents, they are driving Maruti cars only. They are not safe. Maruti cars are not safe because they are made up of plastic. Most of the things are plastic. Therefore, when accident happens, will be no more in this world. So therefore, best car for our Indian roads is, what is best car? Ambassador. But because of the bad appearance, physical appearance, no one is after Ambassador cars. So everybody going after sleek, trendy cars. The reason is we give so much importance to physical appearance. See now, if you see me, so I am with your beard and all, nobody think that I am a educator or something like that. So that's why very few people are attending my classes. Educator should be neatly dressed, neatly combed, right? Put some makeup if possible, right? So that pleases the students, isn't it? That pleases the student. So a person like me, so I am not pleasing the students because of my bad appearance. I am not shaving the beard because I believe in content only. I believe in content. I don't give so much importance to my physical appearance. But that is also important nowadays to become popular in such type of online media, isn't it? In online classes, I want to become a popular. I should improve my physical appearance as well. I should dress well. I should appear well. Then only I can attract students. Otherwise, no students joins me. Even though I deliver good content, but it is of no use. If no one is attending, see now today, no one is attending my class. So it is of no use. Isn't it? I am teaching to camera only now. So exactly, same way. So we give so much importance. Water is not exceptional. Consumer give so much importance to physical appearance. So temperature. Temperature is nothing but measure of heat energy. So water thought to be, water is supposed to be at room temperature. It should not be too high, it should not be too low. Water supposed to be at room temperature. Drinking water which we supply. So it should not be too high, it should not be too low. If temperature is very high, temperature greater than 20 degrees Celsius, then what happens? Promote growth of microorganisms. So water promote growth of microorganisms because microorganisms need warm conditions for their survival. If conditions are there, then no one can stop their growth. They grow automatically. Promote growth of microorganisms. So any impurity in water which promote growth of microorganisms is highly objectionable in water. These microorganisms, some of them are pathogens also. Those pathogens are obligatory parasites. So they kill you. If you drink that water containing pathogens, danger is there for our health, for our life also. Like corona. Corona is an airborne disease. Similarly, there are so many waterborne diseases prevail through water with the help of microorganisms. Microorganisms trigger the growth of pathogens. Some of the microorganisms are pathogens. They trigger the diseases in the community. They break out the disease in the community. So it should not be above 20 degrees. So temperature should not be less than 10 degrees Celsius. So temperature less than 10 degrees Celsius means if it is less than 10 degrees Celsius, then what happens? Viscosity of water increases. Then it is difficult to dry water in a pipeline. Viscosity increases, we need to put more effort to dry water in a pipes. So cost of supply increases. Viscosity of water increases. Therefore, it should not be too high, it should not be too low. So temperature of drinking water should be, you have to maintain anywhere between, as per IS standard, IS 10,500, it should not be less than 10 degrees, should not be more than 20 degrees Celsius. We have to maintain anywhere between 10 degrees to 20 degrees Celsius. Understood? So temperature is measured by thermometer. In any medium, we measure temperature by thermometer. So this kind of questions, no way they will ask, because it is everybody knows. and expressed in India in terms of degree Celsius, and expressed in degree centigrade or degree Celsius. So drinking water standard with respect to temperature is, it should not be too high, it should not be too low. So it is as per IS 10500, which is an open document which is available in internet. You can download it, okay? But so much information is there, but not of them not required. So whatever I wrote here, that only you have to remember. As per IS 10500, right? Temperature in drinking water should be anywhere between 10 degrees Celsius to 20 degrees Celsius. It should not be not greater than 20 degrees Celsius, and temperature should not be not less than 10 degrees Celsius. So we have to maintain temperature in drinking water anywhere between 10 degrees to 20 degrees Celsius, so that safely we can supply water to the public without promoting the growth of microorganisms, without finding any difficulty in supplying the water. By maintaining the proper minimum force, we can reach water. We can supply with minimum effort. We can supply water to the consumer. So that's how temperature is important water quality parameter. Clear now? Next parameter is color. Water thought to be colorless. Any color in water is objectionable. Water is colorless. Any color in water is objectionable to the consumer. Therefore, he will reject it. You notice anything in water, he will reject it. So there are two types of color we can trace out in water. Often we trace out in raw water. One is called apparent color. Usually apparent color is caused by suspended particles, suspended impurities. And second one is true color. So this true color is caused by dissolved impurities or dissolved particles, impurities, particles, all of them one and same one. Apparent color is caused by false color. It appears to be, pretend to be color, but it is not a color in water. Okay, that's called apparent color. Apparent color means false color. And true color. True color is truly color in water. So nothing is pretending in water. It is truly, there is a color in water. So false color is due to suspended particles. Suspended particles, the moment you remove them, apparent color disappear. But dissolved particles cause true color. So even though suspended particles are removed, still color is there in water. So that also you can get rid of by removing dissolved particles. So water thought to be colorless. So color in water is measured by a device known as tintometer. Color in water measured by tintometer. You have to remember this name of this device. And expressed in terms of true color units. In terms of TCU. TCU stands for true color units. So we express color in terms of TCU. What is TCU? Stands for, one TCU means one true color unit means 1 milligram of finely divided 1 milligram of platinum as a chloroplatinate ion. So platinum we mix in water, that produces some color. 1 milligram, if you mix in 1 liter water, whatever color it produces, that is taken as 1 TCU. 1 milligram of platinum as a chloroplatinate ion mixed in 1 liter distilled water. Then the color produced is taken as, distilled water is pure water, 100% pure water, it doesn't contain suspended, it doesn't contain colloidal, it doesn't contain. So distilled water is taken as a reference solution. Always we take distilled water as a reference solution. then the color produced is taken as 1 true color unit. So like this we measure 2 milligram in 1 liter, 2 color units. 3 milligram in 1 liter, 3 color units. How many milligrams in how many liters? Mass by volume. That's called concentration. So color is expressed in terms of TCU. Okay? Or some people express it as milligram per liter. How many milligrams of platinum in how many liters of distilled water? Or milligram per liter is equal to ppm also, parts per million. That way also they can express. But it is measured on platinum scale. So color is measured on platinum scale, platinum cobalt scale. The scaling is called 1 milligram in 1 liter, 2 milligram in 1 liter, 3 milligram in 1 liter, like that 1, 2, 3 color units. That is given by, that is known as platinum scale. Platinum scale, platinum cobalt scale. Some people also call it as Burgess scale. So this color unit also called Hazen unit. It is also 1 TCU is also known. TCU also known as Hazen unit. So it is also expressed in terms of Hazen units. Okay, just remember Burgess scale. So these points you have to remember. And coming to drinking water standard as per IS code, that value is always you have to remember. There is no lower limit. There is only upper limit. As per drinking water standard, it should be better to have anywhere between 5 to 20 color units, 5 to 20 ppm or 5 to 20 milligram per liter. Color units TCU. At any cost, it should not be more than 20 TCU. 5 is not lower limit. 5 is maximum permissible limit and 20 is maximum tolerable limit. So above 20, it is perceptible to human eye. You can notice color in water. So below 20, you can't notice. So anything less than 20, you cannot notice. So preferably, it should not be more than 20. It should not be greater than 20 TCU. If it is less than 5, well and good. Still good it is. So 5 is permissible limit. 20 is tolerable limit. So better to have less than 5. 5 or less than 5 is always better. If not, you can have up to 20, because up to 20 it is not visible to the naked eye. But above 20, it is crystal clear visible. It is perceptible in water. So when it is perceptible in water, consumer reject the water. So therefore, it should be preferably less than 20. Our normal range, acceptable range is 5 to 20 color units. Less than 5 is still better it is. So there is no lower limit, there is only upper limit. Upper limit is 20. For temperature, lower limit is there, upper limit is there. Understood now? Hope it is clear to you. So I'll stop here today because I am not feeling well. So I am feeling, I am suffering with cold, with little fever, but still I managed to teach. So I'll stop here. But before I stop here, I'll request all of you to subscribe to Unacademy platform. Get an exam like experience for GATE and ESE. So they're conducting exams, mock exams. Know where you stand with an All India rank. So they'll give you All India rank. Practice with the test conducted by top educators. Get detailed performance reports with video solutions. Okay, enroll for this. Use my code GATE Civil. You can use my code GATE Civil. So you get some concession also. Then GATE 2023 aspirants Unacademy light test series. So for GATE and ESP aspirants for all branches. So questions is given by top educators. 60 plus tests for all branches. Doubt resolution sessions with experts. Detailed results report for test takers. So duration is 4 months. Price is given there. You can avail my code. So GATE Civil, and you can get some concession also. Okay, this is a promotion event, so we have to do it for making you aware of this, so that you can save money. Unnecessarily you can't fall into trap of so many peoples. So many people, they are trying to attract you, so be careful. So Unacademy features of Unacademy subscriptions, top educators, digital notes, test series, customized doubt solving, live mentorship program, strategy and study planner, interactive open house sessions. Okay, that is also there. Unacademy students. Then see that mobile options also available, plus subscription is available, iconic subscription is available. The rates are given to you. You can also available EMI option. Okay, so these things I know I try to bring to your notice. Before I conclude, yes, little time is there. We can also go with one more parameter. Let us see turbidity also. So I have advertised. So turbidity. So what is turbidity? Because time is there, I don't want to close. Let me cover one more parameter. What is turbidity? Color is different, turbidity is different. What is the difference between turbidity and color? Both of them visible to naked eye. Both of them visible to eye. If water is color you can see, turbidity, that also you can notice in water using your eyes. Naked eye means without any lens you can notice it. What is turbidity? Turbidity is nothing but opaqueness in water. Opaqueness in water is known as turbidity. So opaqueness in water. Opaqueness means invisibility in water. Visibility means transparency. Opaqueness means invisibility. Opaqueness in water is known as turbidity. Okay, so anything is not visible in water. If water is not crystal clear, no object is visible in water, then we say that water is turbid, highly turbid. If objects are visible in water, water is turbid free. So water thought to be turbid free. So drinking water thought to be turbid free. So any turbidity in drinking water is objectionable to consumer. So therefore it is also very important water quality parameter. Okay, so normally the definition of turbidity is turbidity is normally caused by suspended particles and colloidal particles. So suspended and colloidal particles cause turbidity in water. Suspended and colloidal particles cause turbidity to water. Okay, so some people even define it as turbidity is the measure of resistance offered by the water to the passage of light. So turbidity is the measure of resistance to light. If more particles are present, more resistance to light. Less particles are present, suspended colloidal particle, less resistance to light. So things are visible means light is passing through water. Things are not visible means light is not passing through water. Turbidity is the measure of resistance to light. Measure of resistance offered by the particles in water to light. To the passage of light. Light through water. So when light is not penetrating through water, water appears to be turbid. It is a measure of resistance offered by the particles in water to the passage of light. So light is not passing through water. Suppose if I switch off the light, you can't see my face. See now, it become turbid. Room become dark. The darkness is called turbidity. See now, if I switch off my light, what happens to you? I'm switching off my light. Nothing is visible. Only board is visible. My face is not visible to you because there is no light in this room. Light is not there. So if I put light, now I switch on the light. Now light is there. So I keep one box against the light. This box. If I keep this box against the light, still also my face is not visible because this is not allowing light to penetrate through this space. If I remove this box, light is freely passing through this space. Therefore, myself is visible to you. Isn't it? Exactly same way in water also. So if you go to swimming pools, you find crystal clear water. Why crystal clear water? That water is turbid free. If you see through pool water, bed of the pool is visible to you. What color of tile is used in the pool? What is the design they used? If you throw 1 rupee coin into it, that is also crystal clear visible. Same way in the rivers and all, if you go there, throw 1 rupee coin, can you see that 1 rupee coin in river bed? No, nothing is visible because that is very turbid water. Rivers carry turbid water, dirty water. The dirt particles present in water do not allow light to penetrate. So therefore light is not passing through water. Water appear to be dark, dull and dark. The dullness and darkness in water is called turbidity. So technically it is opaqueness in water is known as turbidity, dullness, invisibility. Okay, I hope it is clear to you. So turbidity is caused by suspended and colloidal particles. Okay. Turbidity is a surface phenomenon. Smaller the particle size, more will be the surface area. More surface area, water appear more turbid. Water appear more turbid, more light, water appear more turbid. So turbidity is straightaway proportional to size of the particles. Smaller the size, more will be surface area. More surface area, more resistant to light. More resistant to light, so water appear more turbid. So turbidity is straightaway proportional to resistance to light. And resistance to light is straightaway proportional to surface area of particles. How much surface area of the particles possesses? Surface area of particles. So surface area of particles inversely proportional to size of the particles. Surface area of particles are inversely proportional to size of the particles. So smaller the particle size, more will be the surface area. More surface area, more resistance to light. More resistance to light, water appear more turbidity and vice versa. Understood? Then exactly surface area of particle is, size of the particle is more, then surface area is less. Surface area is less, then resistant to light also less. Resistance to light is less, then water appear less turbid. So vice versa. So it all depends on size of the particle. Therefore, turbidity is a surface phenomena which depends on, so smaller the particle size, more will be. Between suspended and colloidal, which are the smaller size particles? Suspended or colloidal particle, which cause more turbidity in water? Colloidal particles cause more turbidity in water than suspended particles because colloidal particles smaller than suspended particles. Therefore, turbidity is a surface phenomena. Smaller the particle size, more will be the turbidity phenomenon. Understood? If you take a boulder, for example, if you take a boulder of size 1 meter by 1 meter by 1 meter, right, one cube of size 1 meter by 1 meter, how much amount of surface area it possesses? 1 meter by 1 meter by 1 meter. So total surface area is, how many sides are there? 6 sides are there. Each side it is 1 into 1. So surface area of this cube is 6 meters square. If you cut this cube, same weight of cube, some certain weight it has got weight W. Same this W weight cube, if you cut into small pieces, if you weigh the surface area of all these pieces, then how much surface area they possesses? 1 mm by 1 mm by 1 mm, infinite amount of surface area. So size, how many pieces you will get? 10 power 9 pieces. So 10 power 9 pieces, each one is 6 into 1 mm by 1 mm. It is 10 power 9 into 6 mm square. So if you convert this into meter square, how to convert mm square into meter square? By 1000 square. So surface area increases to 6000 meter square. So if its size of the particle cube is 1 mm by 1 mm by 1 mm, right, surface area has increased. How many cubes will get? 10 power 9 cubes you get. Surface area has increased to 6000. If you keep same size cube, surface area is only 6. So it is a size matters. So as larger the size, less will be surface area. Lesser surface area, less resistant light. Less resistant light, less will be turbidity. Smaller the size, more will be surface area. More surface area, more resistant light. More resistant light, more will be the turbidity. Understood? This kind of questions they will ask in ESE exam and GATE exam. Okay? You're supposed to be careful. You're supposed to be very, very careful regarding this kind of questions. Okay? So turbidity in water is measured by, turbidity in water is measured on silica scale and expressed in terms of turbidity units. Turbidity units. Okay? It is measured on silica scale. There are so many number of devices are there to measure turbidity expressed in terms of turbidity unit. One turbidity unit is equal to, right, 1 milligram of finely divided silica. Silica means silica sand. Sand is finely divided. 1 milligram of finely divided silica. Mixed in 1 liter distilled water. 1 milligram of finely divided silica mixed in 1 liter distilled water. Then the turbidity produced is taken as 1 standard turbidity unit. This is called silica scale. 2 milligrams in 1 liter, 2 turbidity units. 3 milligrams in 1 liter, 3 turbidity units. Like that. Produced is taken as 1 standard turbidity unit. 1 standard turbidity unit. 1 standard TU. 1 TU like this. Or 1 milligram per liter or ppm. Okay. So this is proposed by Jackson. It is also known as Jackson turbidity unit. So TU also known as RJTU. It is proposed by Jackson. So people also call it as Jackson turbidity unit. JTU or simply TU or otherwise simply milligram per liter or simply ppm. Like that also you can express. So there is no objection from anybody. You can express in whichever way you are comfortable and convenient. Understood? Hope it is clear to you. So before I close, once again let me show you the promotional content. So avail this offer, GATE Civil, use code, enroll for mock exams, take advice from experts, so they'll guide you. So many tests are there, take them and find out where exactly you stand. So iconic subscription also available. So many subscriptions are available. Okay then, I'll stop here. Again, tomorrow we'll meet same place, same time. Until then, goodbye, bye bye. Shiva Ratri for all of you.